We're going to take a look at how we can use integration to help us find the average y value of a function. So we know a couple of things. We know that the area of a well, we know more than a couple of things, but here's a couple of things we know. The area of a function, or the area of a rectangle, is base times height. And we know that you can find the area under a curve by integrating the function. Let's just draw a little picture of something here. So here's some function, let's say that's y equals f of x. And we're interested in finding this area, let's say, from A to B. So we know that area is equal to the integral from A to B of f of x with respect to x. But remember back that really how we find these areas is we add up a whole pile of rectangles here as n approaches infinity. So we're going to add up a whole pile of rectangles. So really, the area of a function is equal to the limit as n approaches infinity of the sum from k equals 1 to n of f of x k times delta x. So this was what we were looking at earlier on, adding up all these rectangles, and this would be the y value, or the height, shall we say, and this delta x, remember, was the little width between these things, and the height of these things was f of xk would be the y value. So this was the height, and this was the width. And we added up all of these rectangles. So essentially area equaled height times width for each of these rectangles added up. Well, I think you could see, though, that instead of adding up all of these rectangles, a whole pile of them here, just to find the area, there could be one big rectangle, might look something like this, that would have the exact same area, one massive rectangle. And yes, here we're a little bit higher than what we should be, but over here we're a little bit lower than what they should be. And one rectangle would be have exactly the same area as all of these other rectangles added up. And in fact, this height here of this one rectangle would be the average y value. The average f of x, the average y value of that function would be equal to that height. So if we go back to the little concept of area equals base, or width, base times height, then height, isolating for height should be area divided by the base. So how does that look in our formula here? Well, the height, the average x value, this average height should equal the area divided by the width. And we know we can find the area, so let's just go back to our example here from A to B. We know how to find the area of that. That's the integral from A to B of f of x with respect to x. And we know exactly what the width is. The width of this big rectangle would be b minus a. That would be the distance here. So width, oops, having a tough time spelling here. Width would be b minus a. Height, average height, would be average of f of x. And the area we know by integrating. So we can come up with this formula for finding the average height of a function very simply by going, oops, not integral, f of x average, or the average y value, is going to be equal to the integral from a to b of f of x dx divided by b minus a. And so this would be the average y value of that function on that interval. So let's find the average y value of our function y equals the square root of x from x equals 4 to x equals 9. So y average, the y value of average will equal the integral from 4 to 9 of the square root of x with respect to x. That would represent our area. The area divided by the width, which will be 9 minus 4, will simply give us our average y value. So integrating this function, this would be, let's just do this on the side. So remember, the square root of x is x to the 1/2. So then taking the integral of that, I would be adding 1 to the exponent and dividing by the exponent, which would be the same thing as multiplying by the reciprocal, like so. So this would be 2/3 x to the power of 3 over 2, and I'll have to evaluate that from 9 to 4, divided by 9 minus 4, which is 5. So substituting in the 9, that would be 2/3 times 9 to the power of 3 over 2 minus 2/3 times 4 to the power of 3 over 2, all divided by 5. So I got to take the second root of 9. The square root of 9 is 3. 3 cubed is 27. So that's 2/3 times 27 minus the square root of 4 is 2. 2 to the power 3 is 8. So that's 2/3 times 8, all divided by 5. 27 divided by 3 is 9. 9 times 2 would be 18, minus, well, this isn't going to work out nice, so why don't we go back and leave this as thirds. So we'll go 2 times 27, which is 54 thirds. Take away 16 thirds, just so that we can keep our common denominators, divided by 5. And 54 take away 16 would be 38. 38 thirds divided by 5. 5 is like 5 over 1. So we would end up as 38 thirds times 1/5, which is 38 fifteenths. So this becomes our average y value of our function between 4 and 9, I believe it was. Yes, between 4 and 9. So that's how we can find the average value of a function. That's the average y value of a function when we know the area and the width. And we simply divide them to find the average height.